Hi, in this video I'm going to solve this application of derivative with the topic of optimization. This is the second video of this topic. Now let's see this situation. We have a piece of cardboard that is 14 inches by 10 inches, and we're going to cut out the corners as shown below and unfold up the sides to form a box, also shown below. Now determine the height of the box that will give a maximum value. Now here we have a sketch of the whole situation, because I'm using here the same 6 steps that we have been using all along. The first one, which is the diagram, we could say we got it right. Here is the diagram. Here is the unfolded box, and we're going to cut out the corners which the words we're going to cut out this area, this square, this one as well, this one as well, and this one. So we're going to cut out these corners, and the box will look at the end like this. The box has no cover, as you can see. Now we're going to jump to the second step to determine equations. We have to find the height that will give us the maximum volume. So we have to set the volume of this box. Now how can we find this the length of this side of the box and this side of the box? This is a very ugly line. There it is, this side of the box. Now this side of the box will correspond, this one on the bottom will corresponds to this length here. Now this length here, we can find it out by saying this whole length would be a total of 14 inches. Now, but we are subtracting this h and this other h, so this one will be 14 minus 2 times h, and so we can say that it will be 14 minus 2 times h. Now this side, the other side, we can assume something pretty similar. As the whole length is 10, and we're subtracting 1h and 2h, this side will be a total length of 10, which is very ugly. 10, it's a 10 minus 2 times h. So this side of the box will be 10 minus 2 times h. Now the only dimension left for this for the box, the folded box, would be the height, corresponding to this one. It's actually directly h. So we got there. This is a very ugly h. There it is. Now how will the formula for the volume look like? So volume will be equal to this side, which is times this one, that will be the area of the base. So I'm going to say it will be 14 minus 2 times h times 10 minus 2 times h times the height, which is directly h. There it is. Now here comes the thing, which one is the other equation? Now this is kind of tricky, because as we can see here, there is no other equation. So we could say that we have no constraint in this problem, as you can see. But the thing is, or we can say that we are implicitly using the dimensions of 14 and 10 inches to produce and substitute on the final volume. We actually use the 14, these two restrictions, the 14 and the 10, to get this side and this side, and in order to find the final volume. So in a way, we use it implicitly. So there is, in other words, no explicit constraint in this kind of problem. This is not very common, so don't get excited about it. So okay, let's see. So this volume is v of h, as you can see. Now we have to simplify this out. So I'm going to multiply them all first. It would be a 140, 14 times 10, minus 28 times h. Then these two will make negative 20 times h, and then plus 4 times h squared, and it will be times h. Now we can simplify things here. It will look like this: 140 minus 48 times h plus 4 times h squared will be times h. We multiply everything by h. It will look like this: 140 times h minus 40 times h squared, so plus 4 times h cubed. And so this is a volume. I'm just going to fully write this v of h. There it is. This is a volume. This is actually a the function we want to optimize. So we could say then in one step we made 2 out of this list. So number 2 is done, and as well the number 3, as we have no constraint, this one is the function we want to optimize. This volume. So we're done with the third one. Now, but there's no need in this case to do the fourth step because there's no other equation to substitute and to isolate for. So we are going to jump actually directly to the sixth step. So let's see, let's get to it. So we're going to take the first derivative. We're going to use a different color here. Just saying that we're starting with number 6. So v prime of h is equal to 140 minus 48. The derivative of this term will be 96 times h, will be here a plus 12 times h squared. There it is. Now we have to equalize this one to 0. Okay, 140 minus 96 times h plus 12h squared, and we have to find the roots. Basically would be the critical point for this this expression. But the thing is, there's no way to factor this out, so we have to use the general form, the formula, or chicharronera, as you may know it, which I don't know how or why you use that name, but okay, let's forget about it. So I'm going to use it in here. This one is C. This one, this negative 96 is B. And this one is A. I'm going to use a better, different way to sign this out. This one is C. This one is B. And this one is A. So we're going to substitute in the formula, which is, as you may remember, x minus b plus minus b squared minus 4 times ac. This is all over 2 times a. Now we're going to use these values. It will be h equal to negative b will be, I'm just going to sign it out. I'm not going to solve it fully in detail. Feel free to do it on your own. Will be here plus minus, here will be negative 96 squared minus 4. It's a very, this is the ugliest 4 I've ever drawn. Will be a, which is 12 times 140. This is all in the square root, and this is all above 2 times a, which is 12. Now, solving this out, you may find that you're going to find that it will give us, of course, 2 values for x. I'm going to move to the right the screen here so we have more room. Now, which are the 2 values for x that we get here? I'm going to continue over here. The first value of x would be x sub 1 equal to 1.9183. There it is. And the second one, it's going to be 6.0817. There it is. These are the 2 values of x that we'll get from the general formula, from the chicharronera down here. So we get from here, actually, from here, I'm going to use, this is a very ugly line. I'm sorry, I'm very sorry. Over there, we got here. Now, we have 2 critical values here. So how can we work this through? We can use the long process, or we can use a bit of logic to simplify things out here, because as you may see from the original sketch, we can make a few assumptions from here. For example, we can find limits for the value of h. Of course, this x would be of course h, and let me just correct this out because I think I don't want to cause any confusion. This will be h and h. Let's see, be h sub 1, h sub 1, h sub 1 and h sub 2. Now we can make some assumptions from h to find limits for h. Of course, h cannot be below 0 because it wouldn't make like no box at all if h would be below 0. So we could say here that h has to be greater than 0. Now we can assume something else. From this statement here, 10 minus 2 times h, we can safely say that h cannot be higher than 5. If we would have h being higher than 5, we could say that if, for example, if h would be somewhere like 6, would be having this, would be 10 minus 2 times 6 would be minus 12, and we will obviously get here a negative value. And as this is a real life problem, we cannot have negative dimensions here. So we can rule out, we can say safely assume that h has to be greater than 5. So h must be between 0 and 5. So we must comply with this one. And by getting this one, these limits for h, we can safely assume and say that this h sub x, it's not good enough. This one is bad enough. This one is like this. You can see, you may remember what it is for h sub 2. So the right one is actually h sub 1. So we're going to use only basically h sub 1. I'm going to use it in here. We're going to use the same method that we have been using so far. The first derivative criteria. We're going to pick one value before and after. The simplest one here will be 0 and 2. So I'm going to pick here with b prime of 0. You make here as all the values for b prime. It will be 140 minus 96 times 0 plus 12 h squared, which will be again 0. We get that b prime of 0 will be equal to 140. So this is a positive value. In other words, for 0, we'll get here the function is send. This is a very sorry here. It's ascending over here. Now I know that you may all know that it's going to be descending on the other side because you're very smart. You may have noticed this happens basically all the time. So I'm going to substitute here what will be 140 minus 96 times 2 plus 4 times 2 squared. This is 12, I'm sorry. This is 12. Will be 12 times 2 squared, and well, this is the result of b prime of 2 will be equal to actually a positive number. So I'm just going to sign it. I'm sorry, this is going to be equal to negative 10. So that will imply that after this value, the function would be descending. There it is. So as this is ascending and then descending, we can safely assume that that this is a maximum value, and this is actually the value of h, as this is a value of h. I'm going just to write it down below here. When h is equal to 1.9183 inches with this dimension, we will get the biggest possible volume for this example number 2. So we get the biggest, the area with the biggest volume, and then will be basically all of this example.